Good afternoon, ladies and gentlemen. My name's Tearle. I'm from London and I do speak really quickly. So as I'm the last presentation, we're also going to have a little bit of fun. Some of you may remember me from presentations back in 2018, where I took wireless intrusion prevention and I started it with a bank job. Easy. And then I decided it was really important to take Peter Mackenzie and squeeze him into an access point. It was interesting, but he wouldn't really let me do it properly. So this stage, this little area that I'm not allowed to walk out of for the next 18 minutes is going to become a little bit of the United Kingdom. We do drive on the right side of the road with our Australian colleagues and our New Zealand colleagues and our South African colleagues. We're not going to use the letter Z in any of our presentations today. We're going to use Queen's English, King's English. This is a pavement. This will be known as a router for the next 18 minutes, okay? Not a router, a router. But it's all the same thing. Doesn't matter whether you present it as a curb or a pavement, it's all the same thing. And this is the point that we're trying to talk about here is many of the wireless access methods that we have in the industry nowadays use a wireless means of communicating. You know, let's take Bluetooth, for example. If we take Bluetooth, it can handle a lot of data quickly, but it can kill a battery quickly. If we take Bluetooth low energy, it can send lots of little bits of information, but that battery can last longer. I've gone from being a Wi-Fi engineer to moving into the cellular space with Cradlepoint and working in the 5G, 4G environment, and it's really quite confusing sometimes because you hear these words: mobile, PCN, WWAN. A WWAN? You mean we're going to use wireless for a WAN? Actually, we're using cellular, connect to the wireless WAN, and that's great. And we're doing that currently over a cellular network or a private 5G network or a CBRS network. And I just want you to look at this for a second. In a Wi-Fi space, we have client devices. In the cellular space, we call them user equipment. The other thing you'll notice is we have a radio access network or an access point. And I'm going to come into a reason why we at Cradlepoint call it an access point at some point. From a Wi-Fi perspective, we have Wi-Fi. It's just easy. You know, we have 6 gig, we have 5 gig, we have 2.4 gig, but it's Wi-Fi, okay? But we also have Wi-Fi as WAN. So when I drive into a bus station with a router on a bus, that connects to the Wi-Fi in the bus station and then provides a Wi-Fi as WAN service. Very, very similar to what we're doing with the cellular networks. The main difference here is we call it a client device. We may have a controller, we may have a cloud-based controller. From a security perspective, you know, yes, some people still use PSKs, and we know that's a bad thing. But in the cellular space, we're using SIMs. And if we start looking at open roaming, which was a great conversation earlier, we could use the SIM to do all sorts of authentication on a wireless network as well. So, signal levels. It's all about how loud I can hear something, isn't it? From a Wi-Fi perspective, I want to hear things really loudly and I want to hear things really cleanly. From a cellular perspective, I may not need to listen really loudly. Loudly may not always be the best thing. But where's my SNR? Because on that slide, I didn't show you SNR. And if I'm not showing you SNR, you may be hearing really well, but your signal could be awful because of the noise floor that's around you. So, the difference between an SNR and an SINR is related to cellular, by the way, guys, sorry, I jumped that spot, is we're trying to quantify the relation between the RF condition and the throughput that the mask can hear, okay? The important things within in the cellular spaces, we use the RSRP, the reference signal received power. Now, When I first moved to Cradlepoint, I was like, no, it's RSSI. RSSI, great. What's this SINR stuff? And they're like, no, Ian, you don't listen to that. It's the RSRP and the RSRQ that we use within Cellular, and we use calculations on the back of that to actually work out what is the better signal strength that you're going to use, the quality of the signal. And in that RSRP, RSRQ, I think I made that really loud, we have resource blocks. Resource blocks are very similar to OFDMA and resource units, okay? And I'm going to rush through this because I've only got 13 minutes left. But RSRP is almost the same thing, that when we look at it from a mast perspective, by client device, whether it's a router in a police car, whether it's a router in a lorry, whether it's a device that a student is using to learn from, it's an access point, in theory, talking to a client device. But within Cellular, when we start moving towards the RSRQ, which is the signal quality, signal receive quality, the masts start making the decision as to what you're going to connect to. And this is where it gets very interesting, because from a client perspective, this is what we do. I can hear both of these masts at the same signal. But actually, the RSRQ allows me, or it will make the choice for me to which mast I connect to, okay? Tearle put up a slide yesterday, and I thought, hey, he's stolen the slide. But he was talking about Wi-Fi networks. And actually, if we look at what we've got here, we have the same type of devices that connect to the Wi-Fi network as connect to the cellular network. The main difference is, if you're connecting to the cellular network, we're not so dependent on the Wi-Fi drivers in the back end. My honest belief is, and this is why I moved, cellular and Wi-Fi will go hand in hand. There will be none of this handbags going on. It's going to be a hand-in-hand technology. We're going to support each other and help each other. And I keep looking behind me for a screen. I don't know why. But if we look at what we have here, who's seen this before? Look at these data rates. These are exactly the same data rates that we use under a wireless network. We look at the heat maps for coverage zones. We want to estimate the traffic needs. It's the same technology, but we have to look at it in a slightly different manner, and we have to think about it a bit differently. So CBSD. CBSD is basically the American CBRS system. There are a lot of people in this room that know a lot more than I do, because I'm European and we're not allowed it. Okay? One day we might grow up and we might get something like this. But when we look at the power ratings, we look at the outdoor uses and the indoor uses. And I think it was Jim said the other day, we rely on people to go and mount APs, and I want an AP there, and they'll put it there. When you're doing, cellular type deployments, it has to be there, because you have a set of rules that you have to abide by. You have to go and become a certified professional installer. And I understand there's some guys in the room. So if you want to tell me off afterwards, because I've said something wrong, please feel free. Now, this is a router in my loft. The reason why it's in my loft is because my wife keeps getting on my network and breaking things. So now she's got this great little router that connects to the 5G 3 network that's actually up the road from my house. And Jim pointed out from his spectrum analysis the other day the peaks and troughs. It's exactly the same as cellular. It doesn't go, or does it? And I'm going to show you something in a minute. But what I need to know is, if I'm going to try and troubleshoot this from a cellular perspective, I need to know the cell ID. So if I see a problem from my RSRP or my RSRQ, and yes, I have put SINR up there and RSSI, I want to drill down and I want to be able to look at the cell that I'm connected to, use something like Cell Mapper, and I can see exactly what's going on with that cell. 2 months ago, I did a presentation to a very, very large telecoms house, and I had tested this time and time again before. You'll notice on the RSRP and the RSRQ, there is a drop-off in signal for 10 days. One, my wife hadn't been shopping anymore, because when you're connected to a 5G tower and you're using a lot of bandwidth, on a non-standalone, you get the bandwidth that you require. So when I did the demo, I was actually using 4G. So the performance that I was expected to see had dropped from 250 to 300 meg to 25 megabits a second. But it allowed me to show my client what the expected signal strength was. And then when I dropped into the historical data, I could show him the 4G connectivity. So from being a Wi-Fi engineer to a cellular engineer, this is the type of thing that as an engineer, I want to be able to see. I want to be able to visualize, because now I can take that information and I can present it back to my customer and give them everything that they need. Okay, let's do this. Does anyone know what, so I'll tell you what ECIO is. ECIO is used on 3G. 3G in the US and in the UK is being sunsetted. They're turning it off. That's great. If your device supports 3G, it's broke. It's not going to connect. Very difficult to tell whether you're connected to 3G unless you understand what ECIO is. ECIO is energy per chip to the interference ratio. I don't get 3G at my house, of course. But if we look at the ECIO qualities and the signal, they're totally different in the way that they measure it. Everything else that we've measured is in dBm. In this case, this is a static number between 0 and 6, all the way up to 20. So, I want to learn about coverage, I want to do capacity, I want to understand my network. Wouldn't it be nice if, as a manufacturer and a PCN manufacturer, you had the capability to put Humana into your system and do a survey? And yes, right now we have Humana in our system to do a predictive survey, and that's going to grow as far as I understand it. Wow, I've really got through this quite quickly. So, I said to you earlier, APs. If we go back to one of the second slides, where we were talking about radio access networks, we're going to build a PCN network, and we've released the PCN network, and we've confused me because we've called them APs. All right? So when you're talking to us and you're talking to us about cellular networks, we use the term AP. It's interchangeable. Our industry works very closely together. We're not here to compete with one another. And the slides that I showed you earlier, like Troy and Raymond did a great course, from what I understand, using LoRaWAN. I was on a site about 2 or 3 weeks ago where they were talking about all sorts of things. They were using LoRaWAN, they were using Zigbee, they were using BLE, they were using Wi-Fi, and they were using cellular. So where we're coming from is we're trying to be in a position where we're going to be able to manage the access points, we're going to be able to manage the devices, we're going to give you visibility into all the things that you need that is almost the same as a Wi-Fi experience. So, I've got 6 minutes left, and I'm going to the bar. Thank you very much, ladies and gentlemen. Cheers.